Hey guys, welcome back. These are class examples on energy transformations. I want you to understand that the concept comes first and the math comes second in solving these problems. Let's take a look. On 1A, what is the potential energy of the arrow? When you draw back a bow a distance of 0.5 meters and a force of 50 newtons, what do we know if we have distance and force? Well, force times distance tells us the amount of work input into the system. So the system here is the arrow. We're going to input 50 newtons times 0.5 meters worth of work. And whatever work we put into the system is equal to the potential energy we get out of the system. So work is force times distance. That's going to equal the potential energy. The force is 50 newtons. The distance the band is pulled back is 0.5 meters. So the amount of work done is 25 Newton meters, or 25 joules, and that's the amount of potential energy stored in the arrow, or in the elastic of the bow. Here's the second part of that question. How high would the 0.3 kilogram arrow go if it were shot straight up? Now think about kinematics. When an object goes straight up at the peak of its trajectory, its velocity is 0. Therefore, its kinetic energy at the peak of its trajectory would also be 0. Now it does have some height above the ground. We want to know how high the arrow goes. And we also know that we stored 25 joules of energy when we did work on the bow. So what's going to happen here is the 25 joules of work is going to transform into potential energy of the bow and allow it to go up into the air and stop at some given height. Now keep in mind, you can use the conservation of energy equation to solve all of these types of problems. It's just that a lot of the factors will be 0. So the easy way to think about it is work equals energy. So here work equals mass times gravity times height, because that's going to be the potential energy of the arrow. All right, so if the arrow gets 25 joules of energy, it's going to use all of that up to rise to the highest point. The initial kinetic energy of the system is going to be 0. The initial potential energy is equal to the 25 joules of work done. And the final kinetic energy is going to be 0 because the arrow comes to a stop. And the final potential energy is going to be mass times gravity times height. So the 25 joules input into the system will transform into height. We have 0.3 kilograms times 9.8 meters per second squared for the acceleration of gravity. Mass times gravity gives us force, and then the distance is height. So we'll take 25 divided by 0.3, and then divide that by 9.8, and you get 8.5. Question 2, how much work is required to lift a 10 Newton dog up to a 1.5 meter high exam table? Force times distance is work. So 10 times 1.5 will give us 15 joules of energy. Number 3, you compress the spring of a ping pong ball launcher 5 centimeters. We're just going to convert that to 0.05 meters. It takes 25 newtons of force to compress the spring. The ball is 0.05 kilograms. What is the speed of the ball when it leaves the launcher? Now remember, you can use the law of conservation of energy equation, where the initial kinetic energy would be 0. The initial potential energy would be the amount of work stored. That's going to be the 0.05 times 25, or 1.25 joules of work. The final kinetic energy will be what we want to find, because we want to know the final velocity. And then since all of that is going to get transformed into kinetic energy, we won't have any potential energy stored once that spring decompresses. So the 25 newtons is the force times the distance, which is 0.05 meters, will give us the amount of work done on the system. and that's the potential energy, and that's going to transform into the kinetic energy, which is 1/2 mv squared. 25 times 0.05 is 1.25 Newton meters. The mass is 0.05 kilograms, and the velocity is squared. So multiply this by 2, you get 250, and then 250 divided by a nickel, take the square root, you get about 7.1. All right, for the last example, a car with a mass of 500 kilograms speeds up from 20 meters per second to 45 meters per second. How much work did the engine do to speed up the car? Remember that work is equal to a change in energy. And here we're working with velocity, so we are working with a change in kinetic energy. So the work done is going to equal a change in kinetic energy, which we know is going to be 1/2 mass times the final velocity squared minus the initial velocity squared. The mass is 500 kilograms. The final velocity is 45. Don't forget to square that. Then subtract the initial velocity, and that is squared as well, and then get your answer. 0.5 times 500 equals times 45 squared minus 20 squared and that is going to give us 4.06 E5. Okay, we're just going to double check. 45 squared, 20 squared, subtract those two. Multiply by 500, and then multiply by 0.5. Check. All right, if y'all have any questions, send me a message. Thanks for learning.